Hey folks, problem number 3. This is a very popular problem because we're all familiar with soda cans. They're supposed to be filled up to 12 ounces. So notice that they give us a bunch of data, raw data. They actually give us, if you count them, 1, 2, 3, 4, 5, 6 pieces of data. We're going to have to put those into our calculator as a list. And they're saying that the Coke machine is supposed to be filling those cans to 12 ounces. We think it's filling an incorrect amount. Ooh, something different. Incorrect, different. Okay, so our null, remember, is mu should equal something. The alternative is that mu should either greater than, less than, or different. I think we just established that it's going to be different than. And the machine is supposed to fill 12 ounces. Okay, and we're wondering if it fills something different than 12 ounces. Is the machine working fine, or is the machine broken? Is it misfilling things? Okay, we'll figure out the critical value last like we normally do. So let's just throw everything into our calculator. So the first thing we need to do is recognize that we have a bunch of raw data. So we need to enter that raw data into our calculator. It's been a while to put things into a list. So you go stat, and then edit. Yeah, edit a list, enter. Oh, there's numbers there. Go up, hit clear, hit enter. Oh, list is nice and clean. That's L1. So 11.67, enter 12.08, enter 12.12, enter 11.71, enter 11.63, enter 11.92, enter. Everything's in list L1. Cool, hit stat. We're going to do a test. We're going to do a t-test. We hit enter. And remember in the beginning it says raw data or stats. Oh, we have raw data this time. So slide over to data, hit enter. It says, okay, well, what's your mu naught? What's the mu in the H naught? It should be 12. Okay, 12. And what's your list? I put everything in list L1. It sort of does that by default. Thank you, calculator. Frequency, make sure you have it say 1. Every number shows up once. Okay. And then the alternative, different, less than, or greater. We have the symbol different than. So choose that, enter. Slide down to calculate, and then you'll hit enter. And it spits out all the information for us. So we have a test stat. Make sure you write t. T is equal to a negative 1.65. I'll just round it, negative 1.653. And then it says the p-value is 0.1593. Okay. And then let's see, the problem was alpha 05. Alpha 05. How does my p-val compare to my 0.05? It's more than. So if my p-val is greater than my alpha, I fail to reject HO, or as our book says, do not reject HO. Okay. And then, so if we say do not reject HO, then our conclusion in plain English, let's see, do not, so that's not enough evidence to suggest. Not enough evidence to suggest the alternative. The mean fill is different than 12. Not enough evidence to suggest. Maybe you want to say something that makes more sense. The machine is broken, right? This is the machine working fine. This is the machine is broken. Not enough evidence to suggest the machine is filling an amount, a mean amount different than 12. I'll try and keep it simple. Not enough evidence to suggest the machine, and I'll just say that, is filling a mean amount different than 12 ounces. Because we're so familiar with soda cans and them that they're supposed to be 12 ounces, you may say not enough evidence to suggest the machine is filling an incorrect amount, because we all know that the correct amount is 12. So sometimes you can get away with not using a number. So I'd use the number to just be a little explicit there. Okay, now the critical values. So this one's a little tricky because it's a two-tail test. So the alpha is 05, but we have a two-tail test. So I'm going to insert a picture in 1 second. So all you need to do is, so if we draw a picture, because it's two-tail, We know there's a rejection region on the left and a rejection region on the right. We have two rejection regions. Okay, so then if I go to my t-table, the degrees of freedom, oh, notice you could either count the data or you can look on your calculator. It counts it for us. You see how it tells us that n is 6? So that means our df is 5, one less. So we have df equal to 5. So I go to my t-table, df5, and then, okay, I'm going to post a picture. So it's two tails 0.05. So 0.05, two tails, df5, two tails, I see 2.571. So that's going to be the 2.571. And then this location right here, I wish I could draw it underneath, would be the negative 2.571. So this is a rejection region, and this is a rejection region. And we're wondering where negative 1.653 lands. Does it land in a rejection region? Remember, 0 is in the center. So negative 1.653, that lands probably right about there, right here. So it does not land in a rejection region. Therefore, do not reject HO. So if we do the classical approach or the p-val approach, we reach the same statistical conclusion. Okay, so now we're going to do problem number 4 next. Notice that we're going to reach the same statistical conclusion using a confidence interval. Okay, problem number 4 coming up next.